Okay, guys, so I'm going to be talking about the chunking strategy here, just to give you guys an idea, what chunking strategies can be used when you are building a RAG system. Okay, so let's start off with the very important idea behind why chunking matters. Okay, what it is and why it matters. Okay, understanding chunking as the step that determines the smallest unit of knowledge your system can retrieve. So chunking is basically nothing but splitting your long documents, whether it's a PDF or a doc or any kind of file system, uh, splitting them down into smaller chunks, that can be embedded and retrieved independently. Okay, so that's why chunking is such an important task, especially when you are building a RAG system in a vector database platform. Okay, embedding models have token limits, and long text dilutes a single embedding vector's specificity. Okay, so that's why chunking is such an important concept. Retrieval granularity is bounded by chunk size, so you can retrieve half a chunk. Poor chunking is definitely a single most common root cause of poor RAG answer quality in practice. Okay, your LLM model or your custom built or enterprise LLM model will not work properly if you have poor chunking, set up in your backend system. So, a document without chunking is basically a one giant embedding which tries to represent the entire 40-page report. Okay, it can become a blurry average of everything, matching nothing precisely. So the key takeaway over here is that chunking is not a pre-processing, afterthought. It defines the atomic unit of retrieval for your entire system. So that's why it is such an important, step or a building block for building up a good rack system. Yeah. Now, chunk size, overlap, and sliding windows. So those are also important things that you need to keep in mind. Understanding the two core tuning knobs, so chunking before comparing the advanced strategies. So the chunk size is very important. Like, what kind of a size do you need, right, for for the chunk? Is it too small, which basically again loses context, fragments ideas across chunks? Is it too large? It dilutes the embeddings, wastes from budgets. Typical range is around 200 to 500 tokens for pros, so large for code or tables. So you have to figure out what is the best chunk size. Sliding window overlap. Consecutive chunks share a small overlapping region of text. Okay, that's important, and then it prevents the facts from being served exactly at a chunk boundary. So those are some of the things that you have to keep in mind. The overlap illustrated over here in this diagram kind of shows like how the chunk can take place within your document system. There would be an overlap within different text sizes, but that's not to worry about. It's not going to separate out each of the chunk separately in your document system. There would be overlap, so that's okay. But you want to make sure the embedding and the context is being preserved for each of the chunk that is being created, right? So that's more important than having to separate out the documents into various yeah, exactly the chunk sizes that you want. Okay, overlap. The shaded overlap region repeats text, so no boundary fully serves a sentence or fact. Okay. Now, the other thing that you need to keep in mind is that there are different strategies, chunk strategies that you can, implement. So the different strategies are like, you have the fixed size sliding window, okay, which is basically best used for homogeneous prose, quick, prototypes. The trade-off is that it's simple but ignores semantic, the boundaries. Then there is a recursive character splitting. You have a general purpose text with the nested structure. The trade-off is that it falls back gracefully but still size driven. You have something called sentence space, which is short form Q&A, precise citation, can lose parallel level context. You have semantic chunking, which is a long form analytical document which requires embedding calls during chunking, which is the higher cost. You have the markdown aware, which is docs, wikis, readme, style content that is only good as the source formatting, and you have the code aware, which is basically the source code repositories needs language specific parsers like EST based. You have parent child, which is balancing precise retrieval with rich context, more complex indexing and storage. And you have agentic chunking. Okay, my face might be there to explain the best, why is it best for, and what is the trade-off, but it's basically highly variable or ambiguous documents. It has the highest cost and latency and uses an LLM to decide splits. Okay, now, the four chunking strategies that you can look at it side by side. One is the sentence chunking, which basically splits the sentence boundaries, like sparsely, NLTK. Those are probably the things that you are looking at in terms of sentence chunking. The advantages is that it has a precise citation. The disadvantage is that it loses, cross sentence context. The ideal scenario for using this type of chunking strategies, especially in an FAQ or the policy lookups. Then there is something called the recursive chunking, okay, which tries paragraphs, then sentence, and then character splits until the size fits. That might be advantageous for especially for structure where pullbacks. The disadvantage is that it still ultimately is size bound. It's ideal for general enterprise docs. Yeah, parent child chunking, which is good for small child chunks that are embedded and retrieved. Their larger parent chunk is passed to the LLM for context. The advantage is that it's precision and context together. Disadvantage is that it is 2x storage and indexing complexity. So long, technical legal documents. The agentic chunking is an LLM that reads the documents and proposes semantically coherent, split points. Advantages is the highest semantic coherence. Disadvantages that is close and costly at scale. Okay, it's ideal for small, highly valued document sets. Okay, now, let's talk about some of the other things that you might be aware of, but some just to get a knowledge check. How does increasing chunk overlap impact retrieval? Okay, so the advantages is that it improves the context continuity across chunk boundaries, right? And it's better retrieval quality, fewer facts which get served, and it reduces the boundary problems, which is the sentence split across two chunks. The disadvantage is that it has the larger total storage footprint in the vector database. It duplicates embeddings for the same underlying text. It's higher embedding computation cost, and it's slower indexing across larger corpora. Okay, so some of the things that you need to keep in mind in terms of, again, practical recommendation is that start with the recursive chunking at around 500, 300 to 500 tokens, and 10 to 15% overlap as a strong default baseline. Always attach metadata to chunks. Okay, source like section title, paragraphs, pages numbers, last updated date. Those are important when you are building up the chunks. Match chunk strategy to content type. That is, your code needs AST aware chunking. That is, tables need row preserving logic. Benchmark chunk size empirically against your evaluation set rather than guessing. Rechunk and re-embed whenever you materially change your chunking strategy. Old and new chunk sizes should now not coexist in the same index. Okay, so the key takeaway is that there is no universally correct chunk size. Only the size that best serves your context evaluation metrics is what matters. Okay, so that covers up the chunking strategies. Next, we will be talking more about embedding and embeddings system.